This is Thermodynamics Packet, number 2 on page 1. This is a problem about specific heat capacity. Here's the formula for heat capacity. Q, meaning the heat of something, is equal to the mass of that something times a constant called the specific heat capacity constant, and then the change in temperature. So some object of a certain mass has a certain constant, and it changes by a certain number of degrees. It will have absorbed or released a certain amount of heat. Now in this problem, we've got a container that has 50 grams of water in it. Starts at a temperature of 25 degrees C. You have this other object, a piece of metal, starting out at 100 degrees C, pretty hot, and there's 50 grams of this metal. So notice we have the same amount of mass for the metal and for the water. And so the mass term here in this case is going to be equal. And it's going to tend to cancel out. The C for the metal is 0.25, and the units are calories per 1 gram of metal per 1 degree Celsius. So in other words, it takes 0.25 calories to change this metal per gram per 1 degree Celsius. That's for the metal. Now for water, we know it to be 1.0 calories per 1 gram of water per 1 degree Celsius. In other words, it's going to take 4 times as much energy to move the water 1 degree than it will be for the metal. The metal will tend to change temperature easier than the water because of the heat capacity is only 1/4 of water. So if we go over here to our thermometer, we're looking for some temperature, X, shall we call it, and the metal starts up here, so we're going to try to arrive at some temperature X, and here the water is going to go up by a certain amount, and the metal is going to go down by a certain amount. But we should note that, let's not make that X, let's make the change in temperature X. Here the change in temperature for the water is going to be only 1/4 what the change in temperature will be for the metal. Okay, so then we're going to try to figure out what temperature in degrees Celsius this is going to equilibrate at. Well, we know that since this is 4 and 1, we can set up an equation that says that 100 minus 100 plus 4x is going to be equal to 25 plus x. 100 minus 4x is going to be equal to 25 plus x. Okay, I got that right. If we solve for this, we're going to find out what the temperature change is going to be. And remember, we didn't have to worry about mass in this case because since it was the same mass, these mass terms cancel out. Okay, so solving this, we're going to bring the 25 over here. I get 100 minus 25 is 75. I'll bring the 4x over here. That's a positive 3x. That's going to turn out to be 5x. And then dividing both sides by 5, we get 15. So the change is going to be 15 for x, meaning 25, 35, 40. 40 degrees C will be the final final temperature. Since X is going to be 15, I have to add 15 to 25 and get the final temperature, which turns out to be selection B on the packet.